Hey guys, today's lesson on adding and subtracting mixed numbers. So we've already been working with adding and subtracting regular fractions, where we're doing something like this, where it's 2/3 plus 1/4, where we know we have to get common denominators, and then we can go and add them together. Same thing with subtracting. We've done things like 5/6 minus 1/6, and that ends up equaling 4/6, and then you reduce that to 2/3. So we've done normal fractions already. So really the same rules apply where we need common denominators today, but today we're working with mixed numbers. So we're going to be taking stuff like this, where we have 4 and 1/7, and we're adding 2 and 1/5. Again, we're going to need common denominators for the 7 and the 5 on the fraction parts. But then there's rules on what to do with the fraction parts compared to the whole number parts. Then, of course, we're also going to be doing some where there's subtraction too, where you're doing 6 and 1/5, then you might be subtracting 2 and 1/3. Again, common denominators between the 5 and the 7, because anytime you're adding and subtracting, you need common denominators. Before that we get into exactly doing some problems, we're going to just talk about a few skills that we need to know, because these things come up sometimes when you're adding and subtracting. First of all, more so when you're doing addition problems, simplifying part of it, because sometimes when we add mixed numbers together, what ends up happening is we get improper fractions. Now I'm going to write this down because this is something we've worked with already. 10/7. Now we know that if we get an answer of 10/7, we don't want to leave that as an answer because it's an improper fraction, and improper fractions are not okay to have as answers. So what we say to ourselves is this: how many times does 7 go into 10 without going over? Well, it goes into there once. So that gets me to 7. But it doesn't exactly get me to 10. So if I'm at 7, that means I need 3 more to get to 10. So the numerator is a 3, and then that becomes a 7. Now we know how to do that already, but what's going to happen today is when you add mixed numbers together, is you might not just get a 10/7. You might get something like 4 and 10/7. Okay, I'm going to back that up. That was a bad 10. 4 and 10/7. Okay, and we have to know, even though this is a mixed number, it's still not okay to have the numerator larger than the denominator. Okay, so this is what you end up having to do. Okay, when you simplify 10 over 7, okay, you still say how many times does 7 go into 10, and that's just like before, it goes into there one time. All right, and so what you're doing here, get rid of that mess. We're saying how many times does 7 go into 10? Well, it goes into there one time, but that whole number over 1, rather than writing the whole number as a 1 here, so instead of 10/7, it's going to become 1 3/7. That whole number that's a 1 has to be added on to the 4 that's already there. So it ends up becoming a 5. Okay? And then the fraction's still the same. We end up getting 3/7. So you're still simplifying the fraction part, the 10/7. It's just this whole number that you get as part of your answer gets added on to the whole number that we already have. Okay, go ahead and try this one on your own. I'm going to give you one more. Let's give you 2 and 5/3. Okay, try that one on your own. See if you can simplify it. Okay, you're back. So what you should be asking yourself is this: how many times does 3 go into 5? Well, it goes into there once, but that 1 gets added on to the 2 that's already there, which is a 3. Now just worry about the fraction part again. We said 3 goes into 5 once, but that's 3, so we need 2 more to get to the 5. And my whole number is a 3 for our final. So that's one skill that you're going to have, more so when you're adding mixed numbers. The second thing is borrowing. And borrowing, you guys know, happens when we subtract. Okay, so what ends up happening is this. Let's just say I have a whole number 5. Okay, now just like any type of borrowing, if I have to be forced to borrow from the 5, okay, what ends up happening is when I borrow, that 5 is going to become a 4. But something has to happen to that 1 that I borrowed. So that 1 that I borrow is going to become a fraction. So you got to think to yourself, how do I write the number 1 as a fraction? Well, you could write it lots of ways. Basically, you take any number over itself, that's going to be the 1 that I borrowed. So I could write that 1 that I borrowed as 3 over 3. I could write it as 8 over 8, 10 over 10. It's really up to you to choose what you want to write it as. I'll just say 3 over 3 from now. So I borrow from the 5, it becomes a 4. That 1 that I borrowed, I write as a fraction. Okay? So what ends up happening now is, what if I have a mixed number? Okay? If I have a mixed number, like 3 and let's say 2/7, and I'm forced to borrow. Okay? Well, what happens is I borrow from the 3, so that becomes a 2. Now, my denominator stays the same, but think about it. That 1 that I borrowed has to go someplace. So that 1 that I borrowed is like, let's just write it as a 7. So there's the 1 that I borrowed, and 2 7s plus 7 7s is 9 7s. Okay? Now, I want to show you the shortcut to that. So I'm going to back up just a little bit here, and I'm going to do this again. The shortcut to that is this. If I want to borrow from the 3, it becomes a 2. Denominator stays the same. The real trick is the shortcut is if I want to get the new numerator, because it's pretty easy to borrow from the 3 and get a 2. Denominator stays the same. But how do I get that new numerator? Well, in the 2 7s that you already have, here's really what's happened. Just add the 7 and 2 together, you're going to get 9. And that's how you borrow. So I'm going to give you one more problem for you guys to try. Do this on your own, guys. Let's try 10 and 4/5. And I want you to go ahead and borrow from the 10, finish the problem. Okay, you borrowed from the 10, it became a 9. My denominator stays the 5. To get the numerator, you do 5 plus 4, which gives us 9. And that, now I know that that's not okay to have that, but when we borrow, it's just a tool to let us do the problem, and then we're going to get our answer in simplest form. Okay, let's do an example 1. We're going to take 7 1/3 plus an 11 1/3. So, our rules. We must get common denominators. So let's look at our denominators. It's a 3 here, it's a 3 here. So that's all good. We have common denominators. Check. Number 2, add the fraction parts. Okay, fraction parts. 1/3 plus 1/3. Okay, add the numerators. 1 plus 1 is 2. The denominator stays the same. We added the fraction parts. Check. Add the whole number parts. Okay, 7 plus 11 is our whole number. 7 plus 11 is 18. Check. And 4, always, always, always simplify. So that means I look at, can I reduce the fraction 2/3? In this case, the answer is no. If it was an improper fraction part, then I would fix that too. It's not. 18 2/3 is simplified. Check. We're done with the problem. Okay, go ahead and try this one on your own, following the rules. Pause the video, try it on your own. Okay, you're back. Rule number 1 on the other page said, see if your denominators are the same. They are. They're both 9. Okay, so rule number 1, check. Rule 2, we're going to add or subtract the fraction part. So I have to do 7/9 minus 1/9. Well, 7/9 minus 1/9 is 6/9. Okay, step 3, the whole number parts. 6 minus 4 gives me 2, so I get 2 6/9. So then on to rule number 4 is simplify. I know that I can reduce 6/9 by dividing both of them by 2. I'm sorry, not by 2, by 3. Okay, 6 divided by 3 is 2. 9 divided by 3 is 3. Don't forget your whole number. It's going to come along for the ride to get 2 2/3. All right, I will do part A for you here, and then I'll turn you guys loose on part B. So part A, looking at these two mixed numbers, subtracting. I see the common denominators are 7, but the trick here is look at this. When I try to subtract my numerators, 2 minus 5, well, I can't do 2 minus 5 because this 5 is bigger. What I cannot do is turn around and go this way. That's not okay, so don't do that. I can't do 2 minus 7, and if that's the case, this is when our borrowing comes in. Because the 2's not bigger, I have to get that 2 to be a bigger number. So watch this. This is what we practice. I borrow from the 4, so it becomes a 3. I'm going to rewrite this. My denominator stays a 7. I add these numerator and denominator together. 7 plus 2 is 9. So when I borrow, it becomes 3 9/7. Let's just rewrite the other part. Minus 1 and 5/7. Because what you should notice now is, well, now I can do the 9 minus 5. Because I have common denominators. I do 9 minus 5 is 4. Denominator stays the same. Whole number parts, 3 minus 1 is 2. That is simplified. I get 2 4/7. Okay. Part B is for you guys. Go ahead and try it on your own. Okay, you're back. Hopefully what you guys notice right away is we do not have common denominators. So we need to rewrite these fractions with common denominators for 6 and 3. And you probably realize 6 would be a good common denominator, which means this first one doesn't have to change at all. However, the second one, the 3 has to be times 2 to become a 6. So then do the same to the numerator. 2 times 2 is 4. And don't forget to bring your whole number down. Now, just like I did on my part A, We can't do 1 minus 4. So this is what tells us to borrow. Borrow from the 6, it becomes a 5. That 6 is going to stay the same. New numerator, 6 plus 1 gives me the 7. Minus the second fraction stays the same, 3 and 4/6. And now we can do this. Okay? We can do numerator, 7 minus 4 is 3. Denominator stays the same. Whole numbers, 5 minus 3 is 2 and 1/6, which then reduces to 2 and 1/2 for our final answer. I got one last problem for you, and we can do this together. Okay. The bad part is that a lot of people want to do this. 7 minus 5 is 2, and then they just bring the 5/8 along. That is going to be incorrect. We do not want to do that. Okay? So really what we end up having to do here is this. I'm going to rewrite this. 7 minus 5 and 5/8. Okay? I'm going to rewrite that too. 7 minus 5 and 5/8. Really what I want here is I need a fraction part to go along with the 7. So think about how we do that. Borrow from the 7. So let's go back. We're going to borrow from the 7. It's going to become a 6. And then I can get a fraction part, because that one that I borrowed, I have to write as a fraction. Now, this fraction I can write however I want. I can write it 2 over 2, 4 over 4, 10 over 10. I'm going to choose to write it 8 over 8 so that I have common denominators. So the one that I borrowed from the 7, I made into 8/8. And then I can rewrite this as 5 and 5/8. And now that allows me to do the problem. But I chose the 8 so that my denominators were the same. 8/8 minus 5/8 is 3/8. Whole number parts, 6 minus 5 is 1, to get 1 and 3/8. That's our lesson for today.